Guys, in this video we're going to be going over finding some limits from a graph. So say you're given just a graph with a function or a couple functions on it, and you need to find limits at different points. Let's walk through an example of that. So often you'll start with a question that asks you just f of some number, so x equals 3.5, what does y equal at that point? So you go to x at about 3.5, right about here. And if we look, we have an open circle there and a closed circle here. And so that closed circle is actually where we have an existing y value. So we would write 5. Let me go ahead and erase that. Next up, we're looking at a left-hand limit. So we're looking at the limit as x approaches 3.5 from the left-hand side because it's negative. And so let's go ahead and approach 3.5 from the left-hand side. And I like to write a negative on the left and a positive on the right. So I keep track of the left and right-hand limits. So it looks like as we're approaching that 3.5, the value we're approaching is actually 3.5 on the y-axis. And so even though y doesn't exist at that point, that's where our left-hand limit is. And you'll notice the same thing for the right-hand limit as the limit of x approaching 3.5 from the positive side of f of x. We're going down, down, down. We're still approaching 3.5. And so since we have both of those limits equal to each other, our limit as x approaches 3.5 of f of x is just 3.5. So note that even when y doesn't exist at that point, you can still have a limit there. Okay. Let's do this one on your own. So pause the video and take a minute to try to figure out each of these limits. Okay, now let's go through it together. So we start looking at f of negative 2. So here is x equals negative 2. And you'll notice that we have a vertical asymptote here, so we do not actually have any y value that correlates to that. Now if we look at the limit as x approaches negative 2 from the left-hand side, so this is left hand, this is right hand, looks like we're going down, 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 approaching negative infinity. Got approaching negative 2 from the right-hand side, we're going up, 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 approaching positive infinity. Finally, we want to know the limit as x approaches 2. Now, in this case, the left-hand limit's approaching negative infinity, and the right-hand limit is approaching positive infinity. So we just write dne. For our bonus question, let's see if you could answer the limit as x approaches 0. So in this case, once again, we do not have a limit at that point, so we would write dne. And the reason for that is that the left and the right-hand limits do not match. So from the left-hand side, we're going down, approaching, and we're going to end up with a limit of 0.5. And from the right-hand side, we're going up, 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 and we're approaching 3.5. So those values don't equal each other, so the limit as x approaches 0 of h of x does not exist.